Okay, so let us start. Okay. So what today we will discuss, and if you recall, last class we started to discuss generics. And we discussed generic method, and we also discussed generic class. Is it? Okay, so. And so today we will learn more. There is another concept, a new concept is wildcard. That's what we will learn today, okay? And previously when we learned generic, if you recall, we have the type of parameter. So type of parameter is enclosed with the angle brackets T, is it? So it has the type, as we call it a type parameter, okay, type. And for type parameter, it can be bounded and unbounded, is it? So this is unbounded. And it also supports bounded, if you recall. Is it like this case? Is it? So this generic is that extends. Is it? That extends means this T can be the number or its subtype. Okay, so that's called bounded type parameters. Otherwise, like this is just called unbounded type parameter. So they are called type parameter, okay, in our previous discussion regarding generics. Okay, so this is called type parameter. So what today we will see is about wildcards, okay? And for type parameter, is it? So let's see, suppose like this prototype. This copy method, this is a generic method. That this generic method is defined with, so this type of parameter here, it's a bounded one also, is it? And then it has two parameters. The two parameter type are some generic list T, is it? So when you call this method, you can only plug in two arguments. Is it? So two arguments, they must be the same type. Is it? So anyway, the parameter, they must be the same type. Okay, same type. So either like an integer in this case, or double, or something. They cannot be like the first one is integer, the second one is double. That won't work. They must be the same type, is it? But you can like this arg1 and arg2, they can be integer, is it? Maybe later on you call arg3 and arg4, is it? Maybe these two are integer. And these two may be double. That's fine. You can plug in, is it? But the 2, 1 must be consistent in this case. Is it? Okay. So that's regarding generic. Okay. And then let's see. We can also using wildcards. Okay. In wildcards. Okay. So for wildcards, then it's a question mark. So it is a question mark. okay, versus not this T. So let's take a look more, okay, about our examples. Then we will fully understand this. So let's take a look. So over here in this example, this is about wildcard, okay. So for this example, we have four files basically and two packages. We have one for main and we have another package, it's called animal, okay. Within that animal, let's take a look. We have three files. We have animal, class defined. Okay, so this is very general, it's about animal, is it? And then we have pet, and the pet is a subclass of animal, okay. And we also have wildlife, it's also a subclass of animal. So previously we already learned superclass, subclass, inheritance. So nothing new here, is it? And then let's see over here. So in the main, so we have an array list. So ARR1 is an array list. The type is animal. Okay, the type is animal. And then we create one animal, A1. Then we add two ARR1. And we create a wildlife. We also add it to ARR1. That is fine. Okay, because ARR1, the type is animal, okay, and the wildlife is an animal, okay, because inheritance relationship is a relationship, is it? So this is regarding the inheritance, so that is fine, okay. The dynamic binding polymorphism, okay, so anyway, so we add an animal, we add a wildlife, is it? And then we call this add animals. So this is a method. Okay, so let's take a look. This what we plug in is that array list of animal and a wildlife. Okay. So let's see that add animal. So here is this add animal method. It's just a general method. If you take a look, the parts before the parameter, is it? But when we take a look at the parameter, we have two parameters. The second parameter is, as usual, just a type, a wildlife, a reference type. But for the first one, it's array list. But this array list, within it, we have angle bracket, but not T. We have question mark this time. Okay, and we also have super wildlife. So what is this? So basically, this is called lower bounded wildcards. Okay, so for wildcards, it supports lower bounded, upper bounded, and unbounded. Okay, three types: unbounded, and upper bounded, and low bounded. Okay. And what does this mean? It just means the lower bound, it just means you can replace the question mark, is it? With what? With wildlife or its super type. Or it's a super type. Okay, so you can plug in. So this list, so it can be animal list. Is it array list? It can also be wildlife array list. So both in this case, it can take. Okay, then what it does is just add wildlife to that array list. Pretty simple, as it call array list add method. Okay, so this is called a wildcard, but this method itself, not a generic method. Okay, because we don't have that specific angle brackets, the generic mark here, okay? But the parameter use a wildcard, okay? And then what over here we do is we call that method. We plug in ARR1. ARR1 type is what's animal. And the animal is superclass of wildlife. So that works, is it? Okay, so this part we understand. And then next, let's take a look. So here, W1, we create another wildlife, is it? Then we call that method again, is it? So after that, we can print out the list, is it? And we can take a look what we have. Here we add an eagle, then we add a default wildlife. A default wildlife is what? It's just called the super nature, is it? And then we add wolf, is it? And in forest. So let's see the running result of this example. This part, okay. So here we have all of them output, is it? So we have eagle and we have default one, is it? The nature and the nature, the default one. Then we add a wolf, it's in forest, is it? Yeah, so they are correct. And then let's move on to see the next part. The next part, we create a second array list. This second array list type is pet. Okay, then we add some pet. That we add 3 pet. Okay, default one and 2 goldfish. And then next, we call the remove method. And we try to remove P1. Okay, remove the first goldfish, is it? So then let's take a look at the remove method to see how it works. So here is that removes method. It's also not a static, not a generic method. And the parameter then we can see second is normal, okay, just a pet. But the first one, here we saw question mark again. So question mark is wild cards. Okay, but this time to use a keyword extends. Okay, then this case is called upper bound. So this is the upper bound. This is the lower bound, is it? Because it uses super, okay. And this is upper bound, can be up to, is it? Okay, so this is start from wildlife. So this is up to animal. So it can be animal or its subtype. So question mark then represent animal or its subtype. Okay, so then in this case, you can plug in animal because it's subtype, is it? Then subtype is wildlife. It can also take what? It can also take what's this? A pet. So it can take both in this case. Okay. Oh, basically it takes 3 cases: animal, wildlife, and pet. Okay, but it depends on the parameter argument type, is it? And for this argument type, it's a pet. So it can only take a pet, is it? If this type is animal, then it can also take wildlife, okay? But because the ARR2 is pet, so it will only be able to take a cat or the pet. Okay, so that's regarding this one. So lower bounded wildcards, upper bounded wildcards. Then next, let's take a look. The next one, the print one. So this is not a generic. And for this parameter, you can see it's array list, but the array list type is just a question mark. So this is called unbounded wildcards. Okay, unbounded wildcard. And for the method itself, it's pretty simple. Just use for each loop to output every single item from the list. Okay, so this wildcard, then it can take anything basically. Okay, but still not a primitive type because array list can take so any reference type here, etc. And then you may ask, why don't we do object, etc. You can also use the object, okay? But this is more flexible, okay? Because then for objects, your list type should be object, okay? Then in this case, it can be any type, okay? Okay, then let's see the print one, is it? So then you just over here, the array list type is pad. So you plug in. So we can also print it out. Okay, so let's take a look the output for this print. Okay, let's see. So that's after the remove, is it? After the remove, then we have the pad, is it? We have the first pad. The second goldfish is removed. Okay, so it did work. Okay, so that's regarding the print one. Okay, and then next, let's take a look. The last method. Okay, so over here, the last method, the add animal to, okay. And so over here, this is just an animal, okay. So it's not a wild card or generic. So this is very specific, is it? So add animal to, okay. And then over here, so over here, we add the wildlife to the first one, okay, to the first one. And the first one over here, it's animal, is it? So how about let's take a look at this case to see if it's also okay. And did you see ARR2? It's array list of pet, is it of pet? And over here, let's see, here we have the error message. Then it said incompatible type. It says array list cannot be converted, is it? So there is a limitation you can see, even though over here to involve inheritance, is it? But if we use the regular one, is it? Then it has a clearly disadvantage here. It's not as flexible as what we saw the previous one, use wild cards, is it? So for this wild card, it's very flexible, is it? And this case and the print case, is it? Then for this one, then it's, even though you have inheritance relationship animal, you said, oh, why not the pet? But it won't, because it specifically just look for animal. Okay, so that's why, like this case, then it can take both animal and its subclass for the type, is it? So that's why we see this is more flexible. when you compare with this version. Okay. Okay, so that's the wildcards information. Okay, and then let's see. And next, let's take a look. The next example, yeah, over here. The next example is a pretty small one. Okay, so first let's take a look. So over here. So over here, over here we have one class, and this class just has a single main method, so nothing too new here. And we have this second class called defined as max. Within it, we define a method called max. The return type is t, and over here we have that angle brackets. So this tells us this method is a generic method. And the T is bounded type. Is it? So the type, the reference type of T must implement this comparable interface. Okay. Then you have T, two parameter as both the type T, but this T must be some reference type. And reference type must be implements the comparable interface. Okay, it must meet this condition. Okay. And then over here, then in main, we call this method. Is it? We call it, then you will see there is an arrow. Is it a squiggly line? Okay. Squiggly line, if you take a look, then it says basically it's incompatible. Is it? Incompatible. Okay, because what? Because in this case, this is a string and this is integer. Both are different type. Different type, even though both implements the comparable interface. Okay, both of them already implement the comparable interface, but still over here. So over here, it gave us compiling error. So you know, okay, the program has a problem. You need to fix it. And then we need to fix it. So with generic method, it helps us to fix compiling error, because clearly here it tells you error with a squiggly line. Okay. And then let's see, how about let me do this. I comment this and I keep this, okay, but let me comment this out. Me do this. Is it? If it is this case, you will see there is no error. Is it? Let me also comment this part out. Then you didn't see any of the problem, this program. Is it? That's wrong. Then when we wrong, the program has the issue. Is it? Has the issue. And it tells us over here. Is it where the problem is? Is it where the problem is? Let's see. Because why? Because it said you cannot be cast the integer to string. Okay, so here some exception happens. Okay, Then let's get back to the program. Okay, so over here, the problem is, so both the parameter type is comparable, is it? You may see this implements comparable, is it? Implements comparable, but when you call the compared to, this compared to the type should be the same. Should be same. So that's why over here, no compiling error. But when we run, we got error, exceptions. So that can be, in this case, that causes runtime error. This is not good. Is it compile time? Then you as software developer, you can fix. But runtime is you already shift your software. Customers start to use and then crash. That's not good, is it? So this is not a good design, is it? Because over here, then it cannot find this incompatible. Compatible type issue. Okay, because why? Because this C1, C2, because whenever you call compare to, it should be for the same type, is it? So this and this too, the type should be the same, but it's not in this case. That's why it said, okay, there are some casting issue. Okay, so this is not good, okay. That's why over here, is that if we do this generic way, then problem solved, is it? So it will remind you the compiling error, okay, so that you know. Okay, so basically that's one of the benefits for generic. Okay, is to help to find compilation error. Okay, so that's one of its advantages. Then next, let's see over here. We learned wildcard, is it? So you may ask, oh, it's so general, inclusive. Then can we just use question mark for everything? Then problem solved, is it? So can we do something like this, using wildcard as type? No, so you cannot use wildcard as type. Okay, so this question mark is that it's a special actual parameter for the instantiation of generic parameterized. So this question mark can only be associated with the type parameter. Angle brackets. Okay, you cannot just do it using it as type. That's not going to work. Okay, it must be using with these angle brackets. Okay, for the instantiation of the generic type. Okay, so it's not in the definition, cannot be used in the definition. Okay, so be careful here. But T, generic type, you can use it for definition. Okay, so that's the difference between these two also. Okay, the wildcard and the generic. Okay, so that's this example. Okay, we understand. And then what next one? So next one, let's take a look how we design like our stack class as a generic one. Is it? Because previously we learned our stack implemented using array, is it? But at that time, that's just either integer type or character type, something like that, is it? That's not convenient when you want to use different type of stacks in your program. Okay, to make life easy over here, we re-implement our stack class using array, is it? But over here, we do a generic stack. Okay, we still let it implement clonable, comparable, and iterable. Okay, be careful when you implement the comparable, the parameter you should provide should be same as your class type. But for the iterable, the type is T, is this one. Okay, so we need to be careful. And then over here, you declare the array type as what? As the generic. But be careful, okay, because in constructor, we need to create the array called new. You can never do new T with some capacity. That's not allowed. So generic cannot be used to create new objects. Okay, you cannot do that. Then how do we get around? Because the type is T. So normally what we do is we do new object, then we cast it. Okay, so here we cast it. Using object, because object is concrete. Is it? So you can use it to create memory. And the same thing for here. Okay, so that's what we need to change in this case. And the empty, nothing different. And then for the push method, so then the parameter type needed to be changed to generic type. Is it? And here, what we want to do is, in case if the size, is it, is not is already beyond the original array size, then we can recreate new memory. Okay, so we don't worry about stack full condition here. Okay, so here, so each time if stack is full, then we double array size. Okay, we double the array size. Okay, and recopy it. Okay, then the original array is garbage collected. That's about push. And the pop, no difference. Okay, and the pick. So for pick, then the return type also needed to be generic type T. Okay, so we need to be careful here also. And the toString, nothing changed, is it? The clone method basically also not a lot of change. Okay, when we do the array, we do the deep copy. Okay, so here we borrow arrays copy off method. Okay, and this is a deep copy of the clone method. And then for the compare to, also pretty straightforward as before, is it? And then for this iterator, this is from that iterable interface. because of iterable interface, so you can do for each loop. Okay, and the iterator type, this time is a generic. Okay, generic. So for this stack iterator class, this inner class, that we define it to implement the iterator, it's also going to be a generic type. Okay. And then we have next, and the next is return type is T. Okay, return type is also generic. And for the specific item you want to get, then you retrieve, then you use this T, okay, to declare the variable, okay. And then the remove, nothing new. And then let's see, we define it, is it? Then we can go ahead to use it. So in this main, we first declare a integer stack. So for this integer stack, we just add of the item, is it? And over here, we have the search. We have two different search. Okay, so let's take a look at the search method. So for our search method, the first search method, we try to search some number, is it? But for the stack. And here, we also use the wildcard. Okay, so this wildcard, that means it can be number or it's a subtype, is it? So integer, floating, double, is it? All works. And because of this, and over here, we don't want this stack got modified. So we want to create a clone copy, is it? So over here, we declare a stack variable, is it? So the type is stack, but wildcard, is it? And then we call the clone method. And the clone method, then we cast it. Okay, cast it. And then you can do one by one copy, is it? One by one copy. And then, oh, not copy. Over here is we do the search, is it? You get to the top one to see if it is that number, okay? And if it is not, you remove the top item. If it is, then you just return true, okay? So that's how this search item method works. And then let's take a look at search 2, is it? So for this search 2, so here, for the parameter, then it's the same thing, is it? It's wildcard, is it? So upper bounded, is it? So it can be integer, floating, those subtype, and it can also be number type, is it? And over here, we don't do clone, we just use for each loop to do the finding, okay, do the finding. Okay, so that's this method. And then, so we call them to see if we can find the respective item, okay? And we also print out the stack. Okay, so that's the first stack. It's a, this is working on a double stack. And what next? We have an integer stack, is it? And for this integer stack, this time we want to compare this two stack, is it? So let's see. The stack does have the compare to method, is it? So over here, we call the compare to method to compare these two stack so that we know, okay, which one is a larger one, which one is a smaller one, okay. And then the last part, let's first take a look at the running result of this example, okay. Okay, so here we have the running result. Is the first part is to search the item within the stack. And then over here is the output of the stack, is it? And next is still do the search, is it? Well, next is some double stack, okay. Okay, so that's regarding this part, that's not a lot. And then what next, let's take a look. So here, this clean sentence method, it's just a very general method, okay. So it's, you have some input string, it do some cleaning work, it return the new one. How does it do it? So it's going to loop through one by one, okay. So what we will take, so if the specific character within the string, if it is a letter or if it is a digit, then we are going to convert it to lowercase and append it to the string builder object. Then we return the string. Okay, so you will take off. So we will only keep letter and digits. All of the other signs, we will remove them basically here. Okay, so you can use this kind of approach to clean a sentence, clean a string, okay. And what next? Over here, we show is we use our stack, that generic stack. So over here, we create a character stack, and we are going to reverse whatever the string is. Okay, so what over here is we first create a stack. That's it. So from the string one by one, we are going to push it to a stack. Suppose you have a hello. That's it. So what you will have, then you will have hello. H-E, then L, then another L, O. Is it? That's what this char stack is. This char stack is holding, is it? It's holding all of the letters. Okay, holding off the letter, then here you have that reverse string, is it? So it's a string. Then you are going to get the letter out, is it? Get the letter out and append it to the string, is it? And H. So you get, this is a string builder, then you convert it to string, is it? So you get the reversed string, is it? Okay, so that's what over here we show using stack, okay. Using stack, so over here we have some string, and you first clean the string, so it will take off all of the space, okay. And so that's your cleaned sentence. Your cleaned sentence, so that reverse sentence is going to work on the clean sentence. And then you compare the reversed one with the cleaned one. If both are the same, then it is palindrome. Okay, that's the definition of palindrome, okay. Okay, then let's see the result, the running result. Yes, it says that one is a palindrome, okay. So over here, it's just, this example just shows us we use our own generic stack. We can deal with integer stack, deal with double stack, and at the same time, we also deal with a character stack. That so in one program, we deal with a different type of stack, okay. So that's regarding this example. And what next I want to go over is, then let's go back to take like the array list, is it? So now if you take a look at array list, if you see this angle brackets in the official Java documentation, now you understand, oh, this is generic class. Is it? It's a generic class. And then we can also take a look. It's like if you take a look in the Java library, iterable is also defined as generic. Some other one we will learn later, okay? And then let's take a look at the method, is it? Now, when you look at the method, when you saw the, and don't worry, we later on will learn that, is it? But now you understand this one, question mark is tense. So that just means it's wildcard, is it? So it can be type E or it's subtype. So now when you read this official documentation, you can understand what it means, is it? And here again, is it use the wildcard, okay? And then over here, it use that lower bound wildcard, okay? And what else? So over here, it just use wildcards. Okay, anything. So we have wildcards again, is it? And then let's also see, like the contain. Here, be careful, okay? So you see quite a number of the method, their parameter is somehow related with the generic, either lower bounded or upper bounded. Is it related with the generic? But if you take a look, this contains method, it doesn't use generic, because you may ask, why don't you use E item? It's just use object. Why to use object? Is it? So because in this case, if you use object, that's more inclusive. Okay, that's more inclusive. So in Java collection, there are quite a number of methods. They don't use generic, they instead use object. Okay. And then let's take a look over here. Oh, not this one. Let's see. Yes. Over here, okay. So basically, over here, we see we use object instead of the type, generic type. Is it because that's why it can work, is because for this method itself, the return type is just true, but within it, it involves some comparison, the equals. And if you recall the equals method, so object is a superclass. Is it super root class? And within it has that equals method. The equals method plug in is also object type. And when we do the contains, we call this equals, is it? So that going to be more inclusive. And another reason is that can be handled by, we call it a type eraser, okay? And type eraser basically is how generic works, okay? So it's that generic basically in Java, why it can work is because implemented with a technique called eraser, okay, type eraser. Type eraser. Okay, it says if no generic type given, then the type can be replaced with object. Okay, with object. And if necessary, Java compiler can also do the type casting to another object. Okay, if another generic is being given. Okay, so that's why, okay, the generic can work is because of this type eraser. Okay, type eraser. And also in Java, even if you define one generic class, is it? And so we define one generic, but when we can use multiple concrete reference type. Is it? Suppose we have stack, integer, and stack, string. Is it? In Java, you will only have that one be created. Okay, so that's why we call it type eraser. You won't have multiple class be created. You just have a single one that's created. It's just when you go ahead to compile it, it will be, the type will be erased and using this specific type. Okay, so that's the concept here. Okay. Okay, so that's all for today's